Good morning, dear students. Today's topic is determinant. Recall the linear pair of equations in class 11th. a1x plus b1y equal to c1 and a2x plus b2y equal to c2. The condition for uniqueness of the solution was a1 upon a2 is not equal to b1 upon b2, or the number a1 b2 minus a2 b1 should not be equal to 0. If these two equations can be written in the form of matrix, like coefficient of x a1 a2, coefficient of y b1 b2, and because the order of first matrix is coming 2 cross 2, so next matrix should start with 2 cross 1. If you take the product, first row, first column, it comes a1x plus b1y equal to c1. Second row, first column, a2x plus b2y equal to c2. The number a1 b2 minus a2 b1, which determines the unique solution of, is associated with the matrix A. a1 a2 b1 b2. It's called determinant of A. It's symbolically denoted by modulus of A. It is not modulus. Determinant A can be positive or negative. Here is example how to evaluate 2 cross 2 determinant. The first one, 2 minus 1 4 2. This determinant can be solved by 2 into 2 4 minus 1 into 4 as same a1 b2 minus a2 b1. 4 plus 4, it comes to 8. The another example of 2 cross 2 determinant, how to solve it, x minus 1, x plus 1 into x. Simple, it's cross multiplication and minus this. It's x square minus x minus 1 into x plus 1. After solving it comes x square minus 1, that comes equal to 1. Here we will be studying 3 cross 3 determinant also. Like one example of 3 cross 3 determinant. 1 2 4 minus 1 3 0 4 1 0. While we are evaluating the 3 cross 3 determinant, we make minors, because the minors of 3 cross 3 will be of 2 cross 2. We can expand the determinant along the first row or second row or third row or any of the column, first column, second column and third column. Like I am going to expand this matrix along first row. So first row there are 3 elements 1 to 4. 1 2 4. 1 isn't lying in the first row and first column. If I eliminate first row and first column, there is a minor of 2 cross 2 left. That is the first minor, 3 1 0 0. Next element is 2. If I eliminate the row in which 2 is lying and the column, the 2 cross 2 minor left, minus 1 4 0 0. Next element is 4. The row related to 4 and the column related to 4 will be eliminated. And then the 2 cross 2 minus 1 4 3 1. Here sign starts with the alternate plus minus plus minus plus minus plus minus plus. So plus minus, it's plus. If we expand along second row, then it comes minus plus minus, then plus minus plus. The same 1. 3 cross 3 determinant, 0 into 3 0, minus 1 into 0 0, minus 2. 0 into minus 1 0 and 4 into 0 0 plus 4. 1 into minus 1 and this minus 12. It comes minus 52 after solving. But here we solve the determinant using the properties of the determinant. If the same determinant is expanded along the second row, the first element is minus 1. The row related to minus 1 and column minus 1 is eliminated. There is a 2 cross 2 minor, that is 2 1 4 0. Then 3 1 4 4 0. And the last element is 0. There is a minor of 0 is 1 4 2 1. Here sign will come plus, minus, plus, because minus minus plus. When you evaluate the determinant, 0, minus 4, minus 3, 0, minus 16. Here the third one is completely 0, because 0 into something 0. That is minus 4 and minus plus 48. Here minus sign converted to plus sign, minus plus, it comes minus here, though it's already 0. So it's minus 48 and minus 48 or minus 4, it becomes minus 52. So you can expand the determinant along any of the row or any of the column, the value of the determinant will not change. The another case, here we see 1 0 is already there in the second row, so we are not supposed to calculate it. If suppose we expand the determinant along the third column, then minor of 4 will come, minor of 0 obviously it will be 0, then another 0, minor of 0 again 0, then it becomes easy little bit. Let us see. If you expand along the third column, the first, here the sign also plus, minus, plus, 4, first element 4, column will be eliminated and row will be eliminated. The minor is minus 1, 4, 3, 1. The next element is 0. Row and column will be eliminated. 1, 4, 2, 1. The third element again 0. Whatever the minor comes, that will be 0. So here only you have to calculate only one minor. 4, 1 into minus 1, that is minus 12. 4 into its minus 13 and its minus 52. We have seen that we expanded along any of the row or any of the column, the value of the determinant is not going to be changed. While using the property as we done in the elementary transformation, R1 changes to R1 minus R2 or C1 column operations we can apply. But we will try most of the 0, most maximum 2 0 in the same row or same column, that becomes easy for us to evaluate the determinant. One more example of 3 cross 3 I will take, that is evaluate the determinant 3, 0, 5, minus 1, 0, minus 5, minus 2, minus 1, 0. Here determinant can be evaluated along first row or the second row or the third row or any of the column. But if we expand it along first column, there is only 1 0. In second column there is 1 0. In third column is again another 0. But if we go along second row, there are 2 0. It means 2 minors are already 0. The third is minus 1, because the minor of 0 it will become 0. Then the another 0. Here sign minus, plus, minus. It's minus, it's plus. It's minus, 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 it becomes plus 1. The minor of 1 are second row and the column is eliminated. Minus 5 and 3. Here 5 and minus 1. Comes 1, minus 15 and plus 5, that is minus 10. Here is another example of 3 cross 3 determinant. Direct also you can evaluate, expand it along the first row or any of the column or second or third row. But here if you try to bring 1 or 2 0 in the same row or same column, like at place of 1 0 can come, because this is the column C1, it's C2, it's C3. Here it's R1, R2, R3. If we apply one of the operation, C1 changes to C1 minus C2, then it becomes 1 minus 1 0, 2 minus 1 1, 5 minus 4 1, it's 1 1 4, minus 2 minus 3 minus 9. If we try to bring one more 0 at 1 or either at here 1, here 0 can come if we apply the operation, but we cannot apply this time column operation here. Here we will apply row operation. R2 changes to R2 minus R3. Then it becomes 0, 1, minus 2, 0, minus 3, and that becomes plus 6, 1, 4, minus 9. Now we can expand it along first column easily, because 2 minors are already 0 along this one. the column and row will be deleted, plus minus plus sign, the minor of 1 comes, 1 minus 3 minus 2 minus 6, minus 6, and this is minus 6, and the value of the determinant becomes 0. This is the property of the determinant. Another property of the determinant is if any two rows or two columns are identical, then the value of the determinant is 0. Like one of the example here, it's 1 2 3 4 5 6, again 1 2 3. Here two rows R1 and R3 are identical. If two rows or any two columns are identical, then the value of the determinant is 0. Suppose if we apply the operation, R1 changes to R1 minus R3, it becomes 1 minus 1 0, 3 0, 4 5 6 1 2 3. If you expand in along any row or column, the value of the determinant will become 0. If you expand along first row, then you see the 0, the minor of 0 will be 0, and the other also will become 0, so that the value of the determinant will become 0. Third is, another property, if you exchange any two rows, any two columns, then the value of the determinant becomes negative. Like the same determinant, 1 2 3 4 5 6, it's 1 1 1. If any two rows, any two columns are interchanged, then the value of the determinant becomes negative. That will be equal to minus 1 1 1 4 5 6, it's 1 2 3. I have changed R1 and R3 to one negative sign will come. If again you exchange any row and column, then negative and negative would be positive. This is another property of the determinant. Here is another determinant. Using the properties of the determinant, find the value of determinant. Property means either two rows will be identical or two columns will be identical, or the numbers can be reduced using row operations or column operations. Here you see R1, one element 102, it's 17. 17 6 are 102. It's, if we multiply by 6 here, 6 into 17, it becomes 102. It's 3 here, if we multiply by, it's first row 102, 18, 36, second 1, 3, 4, and third row is 17, 3, 6. Here one operation can be applied. R1 changes to R1 plus 6 times of R3. Sorry, minus 17 6 are 102, and 102 minus 102, it becomes 0. 6 3 are 18, 18 minus 18 0. 6 6 are 36, 36 minus 36 0. It's 1 3 4. 17 3 6. Again the value of the determinant becomes 0. This is the property of the determinant. In the same determinant, one 102, 18, 36, 1 3 4, 17 3 6. 102 can be written 17 into 6. 18 can be written 3 into 6, and 36 can be written 6 into 6. Here it's 1 3 4, 17 3 6. Here you see from row 1, 6 is common. While we take 6 common, 17 3 6, 1 3 4, 17 3 6. Again the R1 and R3 are identical, then the value of the determinant becomes 0. In determinant, you can take common from any of the single row or single column, or you can multiply by any element to any row or any column any of the time. But by the same element you will have to divide also. Like one of the example, it's coming. There is another determinant again. We have to prove a minus b, b minus c, c minus a. But easily you can see, we can bring 2 0 here, one in R1, one in R2, or R3 or R2, any 2 0 can be bring. The first operation is going to be R1 changes to R1 minus R2. At the same time you can apply another operation, R2 changes to R2 minus R3. R1 changes to R1 minus R2, 1 minus 1 0. It's A minus B. Here it's BC minus C is coming, B into C minus C into A. The another one again, R2 minus R3, 1 minus 1 0, B minus C, C A minus A. So 1 C A. R3 will remain unchanged. Now you can see from the first column, it's A minus B. This B into C minus C into A can be written 0, A minus B. Here it's minus C common, it becomes A minus B. 0, B minus C, it's minus A common, it becomes B minus C. The third row remains unchanged, 1 C A B. If you see in the first row, A minus B is common because 0 can be written 0 into A minus B. In the second row, B minus C is common because 0 can be written 0 into B minus C. It becomes A minus B, B minus C common. Then inside the determinant is left 0, 1 minus C, 0, 1 minus A, 1 C A. Here one more 0 is possible at R1 or R2, so that the another 0 should not get disturbed. If you apply R1 changes to R1 minus R2, it becomes 0, and that these two 0 will not be getting disturbed, but no need to get another 0, because if we expand it along the first column, we have already two zeros. We can write that the minor of 1, this column, row and column will be eliminated. Now it's 2 cross 2 determinant, which comes 1, 1 minus C minus A, and this is the determinant of 1. In multiplication already there, A minus B, B minus C. If we solve it, 2 cross 2 determinant, it becomes minus A plus C, A minus B, B minus C. That's the final answer. Exercise 4.1 and 4.2 you can try to solve some of the basic questions. See you soon with the next video. Thank you very much.